Hello, my name is Steve Keniston, Storage Efficiency Evangelist for IBM, and I'd like to thank you for taking a few moments of your time to listen to this presentation on IBM's real-time compression. As we all know, data is continuing to grow out of control. What used to be gigabytes and terabytes are now reaching petabytes, exabytes, and zettabytes of growth. Unstructured data is growing at a rate greater than 60% per year, year over year. Information is doubling every 18 to 24 months, and as we know, our storage budgets aren't keeping pace with those great storage demands. It's time to really find a solution to help us attack that problem. The solutions that tend to help us attack that problem are in the realm of storage efficiency. Those storage efficiency technologies come under the guise of thin provisioning, virtualization, tiering, deduplication, and compression. The technology I'd like to talk to you about today is IBM's real-time compression solution. This infographic kind of goes through the different premise of why this technology exists and the value proposition behind the technology. And the upper left-hand side are the core values and goals behind which the technology was developed. Those are the ability to maintain maximum data reduction, even over time, be transparent to all of your applications in your IT environment right straight through to the end user, and to ensure that you maximize and meet the performance and availability characteristics as acquired by the user. The result from that was the IBM real-time compression technology. This technology is made up of 3 components. It has over 35 patents, none of which have anything to do with compression, but how to make compression both real-time and random access. The core engine of the IBM real-time compression technology is what we call the RACE engine, or the random access compression engine. It is where 85% of the intellectual property lives, and it is what allows us to do compression in real time. 2 other key components to the technology are the Unified Protocol Manager. Because the IBM compression technology is an appliance for NAS today that sits between your storage switch and your storage devices, we need to be able to manage the protocols. Additionally is the Monitoring and Reporting Manager. This is the tool that allows you to monitor the appliance as well as see what type of compression ratio you're actually achieving. The key benefits out of this technology are the fact that you're able to maximize your storage utilization even over time without defragmentation to the file. There is no performance degradation in any environment. It meets your high availability requirements and your uptime requirements. And most importantly, there is no change to any of your processes, including snapshots, backups, replications, or archive, even deduplicated backups. This allows you to perform more analytics on more data, to be able to clone or snapshot more data for better data protection, RPOs, RTOs. It's efficient with all of your downstream processes. The hardest thing to change in IT is not technology, it's process. However, implementing the real-time compression technology means there are no changes to your downstream processes. And ultimately, it lowers your total cost of ownership, not just on your primary storage, but on all your data throughout the life cycle. This chart shows an example of the different compression ratios that we are able to achieve through the different file types. As you can see, Microsoft Personal Productivity data, PDF data, 20 to 60% compression ratio. The reason for the wide range is the most recent 2007 Office documents that are stored with a .x are actually compressed. However, we're still able to achieve up to 20% compression on some of those files. Databases get very good compression, up to 80%. CAD/CAM files, engineering files, oil and gas data, that's all vector data that is highly compressible, 70 to 50%. And your virtual server environment getting up to 72% compression. The other key benefit of compressing your primary storage data and having no impact on any of your downstream processes is the ability to gain performance increases and reduce your capacity in your downstream processes such as backup. So 2.5 times less capacity in your replication or your backup, your wire for bandwidth. In your databases, 6x faster backups, 3x faster replication in CAD/CAM environments, 3.5 times decrease in your recovery time objectives. By recovering less data, you can actually recover 100% of your data faster. And 2 times fewer backup licenses. If I can reduce the amount of requirements that I need for my servers to actually move data throughout my environment, whether it be for replication or backup, I can actually decrease my license count, which in turn saves me money. One of the key questions we get is, this technology seems too good to be true. How can you really talk about no performance degradation? There are 3 key factors that allow us to make this claim. The first factor is the fact that by actually compressing the data before it gets to disk, you're actually reading and writing less data. The slowest moving part in any storage array is the disk actuator arm, the mechanical movement of the arm. If that arm is moving less, you actually give CPU cycles back to the array and allow it more CPU cycles to do more work. The second key component, by compressing data before it gets to the array and by being totally transparent to the application, is whatever you end up getting for a compression ratio on disk is actually the factor by which we return your caching capability. What that means is if I have a 2x compression ratio, I'm going to give you 2 times the amount of storage cache. If I never have to go to disk in order to read my data, but I pull it out of cache, I can respond to the application much faster. And number 3, the appliances also have read-ahead cache, a lot like the storage system. In many cases, you may never have to go to the storage array to actually read the data, but read it right out of the appliance. So it's not to say that the appliances don't do work to actually compress the file, but by moving the disk actuator arm less, by providing you more cache both in the storage and in the appliance, we can more than make up for any work that's being done on the file. Additionally, customers that see 70% compression or better tend to see a performance increase. So we've talked about the compression ratio and we've talked about the performance. This chart reflects some of the validation that we've done within IBM to prove our claims. If you look at the top of the chart, what you see is a filer disk utilization chart where blue is essentially better. Blue is with the real-time compression appliance. By compressing the data before you get to the disk, we prove that the disk utilization, as well as the filer CPU utilization shown in the second chart, actually are reduced, giving cycles back to the storage array. This in turn allows you to give the application better response time. In the lowest chart, a TPCC benchmark with over 700 users reflect the response time of an Oracle database back to the application because the data was actually compressed. For more information on this technical validation white paper, please see www.ibm.com/storage/RTC. Now that you have a little bit of an understanding of the technology, let's talk about the implementation of the technology. I would also note that on our YouTube channel, Real-Time Compression, you can see the IBM Real-Time Compression out-of-the-box experience, which is essentially an installation of the appliance. It's an excellent 8-minute video to give you an overview of how the technology is installed. Essentially what you see here are 2 network switches going to the storage with high availability or failover networks. What happens is the appliance is put in place and the ports are configured on the device. Once the ports are configured, you flip over the active ports to the passive ports. You then slide the appliance in place. You configure the other ports, and then you flip your ports back over to the other to the original active ports. Without any downtime at all, you have the ability to install the real-time compression appliance. Additionally, we work with our customers to ensure that once the appliance is installed, we work with our customers to perform the normal high availability failover scenarios to ensure that the appliance can still handle data through multiple paths. Once the appliance is in place, you configure and test the implementation, and you also set up your compression filters. You have a tremendous amount of flexibility for setting up the compression or what you want to compress. You can compress by volume, by share, or even by file type. Once that's set up, you start compressing all the data that is essentially read into the device. So as data is read into the device, per volume, per share, or per file type, that data that has been set up to be compressed will then be compressed on initial write. Additionally, we have technology called compression accelerator that by policy will go in and compress data that already lives on disk, and we call this accelerating your time to return on investment by compressing the data that actually lives in the storage. Okay, so that the technology that you're actually delivering comes in two flavors. There is an STN 6500 model, and there is an STN 6800 model. The 6500 model is a 1 gigabit device and only handles 1 gigabit connectivity, up to 16 Ethernet ports. The STN 6800 handles both 10 gigabit or 1 gigabit connectivity, and you can see the configuration up to 8 10 gig ports or 8 1 gigabit ports plus 4 10 gigabit ports. The system is an IBM storage appliance based on the latest and greatest IBM server technology with multiple cores for enterprise level performance. The technology is deployed in HA pairs, as we saw in the last configuration diagram, and that's how you maintain the high availability through a particular environment. Keep in mind that these devices are not sold based on capacity. The devices are really transparent to the amount of capacity put behind them, while the licensing is sold on, it's a software license that is based on your capacity. The devices from an architecture standpoint aren't deployed on capacity. They're deployed based on your existing network configuration. This chart reflects some of the different use cases and customer examples that you could actually find on the YouTube channel or on the ibm.com/storage/RTC site under our case study section. So Shopzilla, who is an EMC data domain customer, was not only able to see an increase in their storage efficiency by 50%, but they were able to see a reduction in their backup windows by 25% with an annual growth rate in their environment of 200%. What's interesting is they back up to deduplicated disk, the data domain device, and we'll talk about how the RTC technology or real-time compression technology works in a deduplication environment where other competitive technologies do not. Polycom in Israel was able to see a 75% or a 4x smaller storage footprint for their home directory data, as well as reduce their backup window and replication costs. Sendwise in South Africa was able to see an 83% smaller storage footprint for their Oracle and SAP environment. And here's an excellent example of Oracle on NFS, where high compression ratios actually turned into greater processing time or better performance. Mazda in Japan, a CAD/CAM environment, was able to see a 67% smaller storage footprint for their CAD data, and essentially they were able to keep more of their archive data available and online to be able to be more efficient when doing their next evolutionary drawings. Let's talk a little bit about how the technology actually works in a deduplicated environment. This is really important. Given the fact that one of the best storage technologies that has been deployed over the last 5 years for backup has been deduplication, it wouldn't make a lot of sense to deploy a technology that screwed up any of the downstream processes. On a competitive level, companies like EMC and NetApp will talk about the fact that you must decompress your data before you actually back up, because the compressed data will not be advantageous to your deduplication ratios. In the example on the left-hand side, or let's start in the middle, the example in the middle is a file that is compressed essentially a 3-to-1 compression ratio. On the left-hand side, what you see is a modification made to that file in the middle. Now what you have is the mn function having been put in the middle of the file, and then the file is recompressed. What you see is everything after the first block has been shifted. So the commonality between the first compressed file, or the original compressed file, and the new compressed file, there is only one common block. So from a deduplication perspective, it's not very efficient. What you see on the right-hand side is an example of how the real-time compression technology actually controls what happens inside the file and actually aligns very well to the deduplication technology. Just because the addition of mn was made in the middle of the file, actually in the compressed file, it's added to the end of the file. and the middle block is actually flagged as an available block for additional storage upon the next write. What you now see is that A, B, C, D, E, F, and G, H, I are common with the original file. Because of this, you've maintained your deduplication ratio, and the only new add to the file is the small mn at the end of the file. This is how the IBM real-time compression technology is able to exploit data deduplication and actually make your backups faster in those environments. So while that technology actually has an interesting theory, what you see here on slide 11 is the technology in practical use with IBM's ProtectHere technology, which is a deduplication technology. And while it's impressive that the original storage savings with deduplication was 82%, and then once compressed it was 96%, what ends up being most important is the third bullet down, or the third sub-bullet, which is a 71% reduction in backup time. Customers continue to struggle with backup, and anytime you can reduce someone's backup window by 71%, that is an incredible help to any storage administrator's backup challenge. Additionally, on slide 12, we see similar results with the EMC data domain solution. Again, a 40% improvement in capacity and a 72% reduction in backup time. Again, this reduction in time being very valuable to IT as they look to, as data continues to grow, to be able to perform their backups. Slide 13 is an example of a VMware environment. When we talk to customers, we find that the implementation of VMware has actually caused a tremendous growth in their storage environment. So when you had your old server paradigm with a number of servers utilizing X amount of capacity, as you moved to the virtual server environment, we're actually finding that it's causing IT to have 4 times the storage growth. That growth in capacity is really not seeing a savings in the overall IT budget. It's just seeing the IT budget shift from servers to storage. By implementing the real-time compression technology in front of the storage behind a VMware environment, you can have a profound effect on the capacity that VMware requires. Assuming a 75% compression ratio on VMware data, you can now start to get control of that capacity growth and really balance your storage budget. What's nice about the real-time compression model is that it aligns very well to the VMware model. Essentially, it's do more with less physical stuff, which ends up equaling efficiency. So if you get 72% compression on your primary storage, that's 72% less data that you would have had to have backed up, 72% less data that you would have had to store in the backups. Your backup windows shrink by a factor of 4. You're allowed to get more RPOs to increase recovery capabilities. Your recoveries take much less time, and you reduce your overall costs throughout your environment that you knew you were going to have to pay just by deploying VMware. So you can really get control over your storage growth. So let's take a use case. This is a backup and replication use case. What you have before you is clients connected to some storage, snapshots, some SnapMirror, which is the replication component, over to a remote site where that site also has some storage and some snapshots for recovery. Additionally, both sites perform NDMP backups because they couldn't consolidate their backup environment given the fact that they had so much data, and then they were off-siting some of that data on tape. On the right-hand side, what you see is the same environment with the deployment of the real-time compression technology. By performing compression on the primary storage, you don't need to expand your storage footprint. Additionally, you can replicate less with your SnapMirror technology. You have more capacity, or by leveraging the same capacity for your snapshots, you can put 2 times the number of snaps, or whatever your compression ratio factor number of snaps. This allows you for better RPOs and RTOs, and you have, as we said, more efficient replication, which provides faster backup and archive times. Additionally, you're having less tape, as well as less overall volume of data to back up, which means you can now consolidate your backup environment, meaning a reduction in software licenses as well as hardware and hardware licenses for an overall efficient environment. This particular scenario is actually a use case straight from one of our customer case studies. Allianz in Europe was faced with unprecedented data growth in their primary data environment, their primary storage environment. They were replicating data to a secondary environment. They were going to need to grow capacity in both environments. Additionally, the business had put some mandates on them to, one, control growth or control spending in IT at a 1% growth rate, as well as meet the demands of the capacity growth requirements, as well as better RPOs and RTOs on their within their existing environment. They were able to deploy the real-time compression technology, see a significant savings in their primary and secondary footprint, allowing them not to be required to go acquire more capacity. They were able to meet the business objectives of having better recovery time and recovery point objectives by leveraging the same volume that they were originally creating their snapshots in, but doubling the number of snapshots that were available to them. And they were able to reduce their overall bandwidth cost for replicating data. Additionally, they were able to consolidate their backup environment to one environment and move less data to tape, saving both in the tape costs as well as the backup licensing and hardware licensing costs for their backup environment. Another benefit that came out of this environment was they were able to perform analytics on much more data, learning a lot about their customers and helping them to drive better margins and better customer user experience. So the key message is really the ability to give your storage more space, not only on primary storage, but throughout the data lifecycle. It's important to remember that whatever savings you get in your primary storage capacity, you're going to get in your disaster recovery environment, in your remote offices, in your archive environment or your secondary storage environment, as well as your backup environment, whether it be tape, virtual tape, disk-based backups, or even deduplicated disk backups. Your overall CapEx and OpEx savings throughout the data lifecycle is going to be tremendous. Just by deploying this technology in front of your primary storage, you're going to get all these downstream savings. There isn't another technology available on the market today within the storage industry that can provide the type of savings that the real-time compression technology can provide to you. I want to thank you all for taking your time today to listen to this presentation on IBM real-time compression. My name is Steve Keniston. Thank you and have a nice day.